Hi and welcome to this video where I'm going to start by introducing the concept of titration curves. Now, as part of this standard, you do need to be able to interpret and use titration curves and then calculate the pH at various places throughout that titration. So, first off, a titration curve is a graph that shows the change in the pH as the titration progresses. So it's effectively a graph where the x-axis has the volume of titrant that's been added and the y-axis has the pH. And you need to be able to interpret these curves. So you need to be able to calculate the pH at different points, look at what's present, and identify some different regions within that titration curve. So what does the titration curve look like? Well, they look different depending on what's actually being used. So this is the titration curve of a strong acid and a strong base. So think HCl and sodium hydroxide. The equivalence point, which you can see on this graph, it's this sort of the middle of the straight section, that straight vertical section. The midpoint of that is the equivalence point, and that is the point where all of the original acid has been exactly neutralized by the added base. Now, we do call it the equivalence point and not the neutralization point for a very good reason, because it's not always at a neutral pH. For a strong acid and a strong base, the equivalence point is at a neutral pH, that is a pH of 7. But different types of titrations have different shapes of titration curves and different equivalence points. So please just allow me to show you those for a moment. So first off, okay, this is the curve for a strong acid and a strong base, and there are a couple of things to note in this. First one is that it has a very sharp flat line at the bottom and quite a flat line at the top. There's not a lot of, so it's pretty much just three straight lines joined by some little curves. But different types of acid-base titrations look different. So on this, I'm going to attempt to sketch what you might get if you have a strong acid and a weak base. So if I have a strong acid, it's going to start off looking the same. It's going to come up, but the weak base is going to give me much more of a kind of curved line at the top. It's not going to come up on that sharp bit the same way. And so if you have a look, the midpoint of that horizontal, vertical part of the line there is a little bit below 7. So that's the equivalence point for a strong acid and a weak base, and sort of what the shape looks like. In contrast, if you have a weak acid and a strong base, it looks different again. You kind of get a curve that looks something more like this one, which is a weak acid and a strong base. And here you can see that the equivalence point is actually greater than 7. Okay, I'm not going to bother about a weak acid and a weak base at this point because they don't tend to come up in this standard, but for a weak acid and a weak base, you can kind of combine the bottom part of the weak acid strong base titration and the top part of the strong acid weak base titration. Okay, so when you look at a titration curve, there are several regions in that curve that you need to be able to identify and you need to be able to calculate the pH of. The first one is the initial pH and the initial point. That's pretty obvious, it's the starting point of your titration. Half equivalence point is when you've added exactly half the volume of your equivalence point. The buffer region I'm going to show you in just a moment. The equivalence point obviously is the midpoint of that vertical line, and then after the equivalence point is what happens next. And so you need to be able to identify those things on a curve, and you need to be able to calculate the pH at any of those points. Now the most important area, really, is the buffer region. So I just want to show you that for a moment. So this is your weak acid, strong base titration, and you can see a couple of things on this, I hope. The first one is this is where your initial pH is sitting. Okay, so it's going to be somewhere greater than Yeah. And you'll see there's a little curve as it jumps up immediately, and then it goes through this flat period. And this flat section here is your buffer region. And if you'll remember, a buffer is formed when you've got a mixture of a weak acid and its conjugate base. And this is really important because, of course, if we start off with a weak acid and we add some strong base, we're actually converting some of our weak acid into its conjugate base. So at this point, we're basically making a buffer system. We have our equivalence point, which is halfway through this point. Halfway there, about 12 mils, is this point. And at this point, the pH is equal to the pKa of the weak acid. Okay, and that's actually very, very important, and I'll talk about that mathematically in another video. But those are the key things that you really need to be able to identify when you're looking at these titrations. So just a couple of notes about the equivalence point in a titration. The equivalence point is the point at which all of the acid that you've started with has been neutralized by the added base, or if you're starting with a base, all of that's been neutralized by the added acid. It's going to happen at different pH levels depending on what type of acid and base you have present. So if you have a strong acid and a strong base titration, the equivalence point will be neutral pH, so it'll have a pH of 7. But if you have a strong acid and a weak base, then your equivalence point is going to be more like a pH a little bit less than 7, maybe 5.5, 6, because your weak base is being converted into its conjugate acid during the point of that titration, which is going to lower the pH at that equivalence point, because you're not going to have a neutral salt and water, you're going to have a weak acid and water present. Conversely, if you have a weak acid and a strong base titration, the equivalence point is going to have a pH of greater than 7, often around somewhere between 7.5 and 9, because your weak acid is going to be converted into its conjugate base, which is going to raise the pH at that equivalence point. If you have a weak acid and a weak base, the equivalence point is going to be back to a pH of 7, because your weak acid is going to be converted into its conjugate base, but the weak base is converted into its conjugate acid, so it all kind of cancels out. So those are really the key ideas around titration curves. In the next video, or possibly two, I'll be looking at how you calculate the pH at different points throughout that titration and how you justify some of your discussions. So please do join me then. Thanks, bye.